Let's put this famous equation to use in our first example of Newton's law of universal gravitation. We must determine the gravitational force between a bowling ball and a golf ball held 2 meters apart. The universal gravitational constant g is also given in the problem, as it will be most times. To find the force between these two objects, we start with F equals gmm over r squared. We know the values of g, capital M, and lowercase m. So we plug these values into the equation and we get F equals 6.67 times 10 to the power of negative 11 newtons times meters squared over kilograms squared times 7.8 kilograms times 0.04593 kilograms. Because remember, mass must be in kilograms when we plug it into our equations. This entire numerator is divided by the distance of 2 meters squared. We can cancel all of the kilograms in the numerator and carry out the multiplication to get 2.69591 times 10 to the power of negative 11 newtons times meters squared over 4 meters squared. Now, the meters can cancel out, leaving behind only newtons, which is expected as the unit of force. So when we divide, we get 6.73976 times 10 to the power of negative 12 newtons, which we can round to two significant figures because of this number, and we get 6.7 times 10 to the power of negative 12 newtons. In the second example, let's explore what happens to the gravitational force between two objects of mass capital M and lowercase m if their distance is decreased from 5 meters to 1 meter apart. Again, we start with F equals gmm over r squared, but instead of replacing all of these variables with numbers, we're only going to work with the variable r for the distance. Originally, we have a distance of 5 meters, so we replace the r in the denominator with a 5. 5 squared is 25, so we get F equals gmm over 25, or 1/25 of gmm. After we've moved the objects closer to a distance of 1 meter apart, we can now analyze the same equation using 1 for r. So we have gmm over 1, which is just gmm. So the gravitational force after the masses are moved closer together is now 25 times stronger than it was before.